All right. Hi there, POA. Oh, I got a little echo going on. That's a little better. Um, we're going to take a look at this homework. This is 2.1. I'm recording this before our class, so I'm hoping things go really well today. You can tell it's 7:38 a.m. by this little marker right here. But we're going to take a look at this homework. It's going to talk about some of the things we talked about in class today, including some things about the brain and a little bit of math work as well. Okay, so let's look at this first set of problems. So it says, myth and the brain. Have you ever heard people say that adults do not grow new brain cells and all development takes place in childhood? Humans use only 10% of their brains. Um, we learned today, and hopefully this solidifies it, that both those things are myths. They're not true. Scientists have found that the brain continues to grow and change well into adulthood, and they've also shown with advanced MRI imaging that humans use most of their brains, not just 10%. And that's called neural plasticity, if you want to know a really cool word. It means that our brains are able to change well into adulthood. Um, so in the past decades, results from brain research have changed ideas about intelligence. For example, scientists have learned a person's mindset. I'm going to go ahead and circle that word because it's such an important one. Is very important to his or her mental success. So mindset is sort of how you think about what you are up to. It's sort of your perspective. Rather than focusing on obstacles or worrying about whether they can do something, people who are mentally successful focus on what is necessary for solving a problem or meeting a challenge. And so it's about thinking uh, about what is important in the moment. Being able to put aside like personal feelings or maybe put aside distractions so that you can focus a lot on what's going on. So let's look at the question. What are some myths about intelligence that you have already uncovered in this course? And so I'm going to write, because we talked about this today in class, um, I'm going to write this. I think that uh, a myth is that people are born a certain level of smart. And we talked about that today. Um, in class, we talked about how the old idea about intelligence or smartness is that you're just some level of smart. But we know that that's not the case because there's all these things that happen in our brains, dendrite growth and axon growth, that can allow you to increase your intelligence over time. And so that's a myth. What are some ways to increase the number of dendrites you have and thus become smarter? I'm going to write try hard things. I'm going to put a semicolon, then try them again. It's just a way of saying you have to challenge yourself. There's no way to get smarter without trying hard. It's just the way that it works. And so you can almost think about like a toddler when they're trying to learn how to walk. The more they try to walk, the faster they get good at walking. It's just the way that it works. And that's a brain thing. Their muscles can do it. They just have to learn how to control it. So when they try hard things, they get good at them more quickly. The same thing is true for um, adolescents and teenagers and adults. Okay, so let's look at this next problem. So it says apply the skills and strategies you learned in the bike and skateboard problems. And so immediately what I'm thinking about is we had organized tables and we also used guess and check. And so those are the strategies that are already in my head because I know we've talked about those in class. All right, so we've got these rectangular tables and they're arranged like this. So I see the first, if you have one table, you have 6 people that can sit in it, 2 on the top, and there's the 2 on the top, 2 on the bottom, 1 on each side. All right, you add another table, and it looks like these sides touch each other here. And so when I look at that, it seems like we've added a table, but we've only added, I'm noticing a relationship here, we've only added 4 new people, and here they are. There's the 4 new people because this person is right there. And let's see if the pattern continues. Alright, so we've added another table. Here's 3 tables, and there's 4 new people. And this person again is on the end, so I have plus 4 again. So, alright, so let's take a look at a little bit more of this information. There's a relationship between the number of tables and chairs in each row. With this in mind, answer the following questions and provide evidence. So evidence means we need to make an observation. Some things we've already noted above. Just processing the question. If the pattern continues, how many chairs will fit around a row of 5 tables? Okay, so one table had 6, 2 tables had 10, 3 tables had 14. I'm going to start making a little organized chart. And so I'm going to make a table, and then chairs. And so I'm using this organized table strategy. Alright, so one table gave us 6 chairs. That's the first image. That's this image here. Then 2 tables gives us 10 chairs, and that is this diagram. 3 tables is going to give us 14 chairs, and that is coming from this diagram. And so now we're going to be good pattern hunters. The number of tables is going up one each time, so that's going to jump to 4. And so this is jumping by plus 4 people. We talked about that a little bit ago. And so it's going to continue, I think. We're going to add another table, and we'll get to 18. Then we'll add one more table, and we'll get to 22. And so I think how many chairs will fit around 5 tables? It's going to be 22, because each new, going to kind of write like this, table adds 4 chairs. Alright, 11 tables. Ooh, it's getting a little bit more complicated. I'm going to use some space down at the bottom to continue my table. So I'm going to have 6 tables, then 7 tables, then 8 tables, then 9 tables, then 10 tables, and then all the way up to 11. And so from 5 to 6, it adds 4 to 22 here. And so I'm going to add 4 to that. I get 26. Add 4 to that, plus 4. I'm going to scroll up a little bit and try to do a better job of writing that. Plus 4 gives me 30. Plus 4 gives me 34. Plus 4 gives me 38. Plus 4 gives me 42. And plus 4 seems to leave me with 46 chairs for 11 tables. So I'm going to get 46 chairs. And the evidence I'll give is look at the chart I made. That's good evidence. We have it right here, and I'll even highlight the part that's important. Just to color code some things. And now I'm going to look at this next question. How many tables are needed to seat 30 chairs? Well, in order to seat 30 chairs, it looks, if I look at my table, I'm going to get my highlighter out here again. If I look at my table, or my chart here, 7 tables gives me 30 chairs. And so I'll even make a little arrow here and point here and say 7 tables makes for 30 chairs. And I'll highlight that so it's a little bit clearer what evidence goes with what. Cool, so we got the front of the page done. Let's look at the back. Okay, so complete the square box problem. So today in class, you guys did a really nice job of, this was yesterday in class, excuse me, yesterday in class we did a really nice job of finding the pattern that goes with these. And so we noticed that to get the top box, you have to take the two numbers on the side, -2 and -7, and you have to multiply them. And so -2 times -7, I'm going to think about the negatives or positives first. Negative times a negative makes a positive. So I'm going to put a little positive sign. That's what I do to try to remember it. And then I just do the numbers. 2 times 7 gives me 14. And so I can write my answer of 14 here. Then we found that the bottom box, the bottom triangle, you have to add them. So -2 plus -7. And you can think back to some of the number line stuff that we've done. If you're at 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So if we start at -2, and then we add a -7, that's like taking away 7. So we're going to take 7 steps this way. 1, 2, 3, 4, 5, 6, 7. And we end up at -9. Of course, you don't have to show this part every time, but if it helps you, totally do it. Because we're asking you to do some mental math so we can get better at this stuff. The point is to get automatic with it. If you remember our talk about Michael Jordan. All right, what is the sixth term in the sequence below? So a sequence is a number pattern, and so term means that this is the first term, second term, third term, fourth term, and so we need to figure out the fifth and the sixth using the pattern. So the first thing we need to do is try to identify the pattern, and so it seems to go from 4 to -8. And so I'm going to brainstorm some ideas. How do I go from 4 to -8? And one thing I could do is I could, just brainstorming here, take away 12. 4 minus 12 is -8. And so I'm going to, that's what my first guess. And so then I'll see if it works the next time. -8 minus 12 gives me -20, but I was supposed to get 16, so that's a problem. So I'm going to back up. It seems like my subtract 12 isn't going to work, so I'm going to guess something else. So 4, we're going to do something to it to try to get -8. So I'm going to try multiplying. Now, when I think about trying to get from 4 to 8, I know if you do 4 times 2, you get +8. And so 4 times -2 will give me -8. And so let's see if that works on the next one. So -8 times -2 equals -16, and that works. That's what we're supposed to get. Sorry, +16, because a negative and a negative make a positive. And then if we do +16 times -2, we get -32. And that again checks out. So it seems like our pattern is to multiply by -2. And so I'm going to do 32 times -2 equals, 32 times 2 is 64. And a positive times a negative makes a negative. And so then I'll do -64. So that's the fifth term. -64, +64. Ooh, I need to back up a little bit here. I apologize, I made a little mistake. So I should be using -32 here. And so I'm going to think through that again. I just made a little error. So I'm going to back up. 32 times 2, 64. Negative times a negative makes a positive. And so the fifth term should be +64. And so now I have 64 times -2. And so now I have a positive times a negative. That makes for a negative. 64 times 2 is 128. So I get a -128. So that is my sixth term. Let's look at this reasoning problem. Each type of ball represents a different digit, 0 through 9, that remains consistent across all three equations. Figure out the number that matches each of the balls and explain your reasoning. Okay. So the first thing I notice here, I'm just kind of looking through stuff, is I see that basketball plus basketball equals football, and basketball times basketball equals football. So we have something where the same number is added to itself and it gives something, and then it's multiplied to it by itself and it gets something. And so there's a couple of ideas that come to mind. There's two possibilities. So you could do 0 plus 0 equals 0 and 0 times 0 equals 0, or 2 plus 2 equals 4 and 2 times 2 equals 4. So that's what I think the two possibilities are. I'm going to look at the next clue, the second clue here, to see which one may be right. And so I see football plus soccer ball equals football. So that sure seems like the soccer ball isn't doing anything to the football. So that means the soccer ball definitely has to be 0. Because when you add something and get the same thing back, the soccer ball has to be 0 then. So I'm going to write soccer ball is 0. And that doesn't actually tell us which of my two ideas is right. 0 plus 0 equals 0, or 0 times 0 equals 0, or 2 plus 2 equals 4, and 2 times 2 equals 4. So it seems like I have two possible answers. The basketball could be 0, or the basketball could be 2, and that will change what the football becomes. So there's two possible answers. I'm just going to write those up here. Basketball is 0 or 2, and the football is 0 or 4. All right. So 0, 2, 0, 4, and we know the soccer ball has to be 0. And I'm just going to make a little arrow here for my evidence because I worked a lot of stuff out over there. You're traveling down the interstate averaging 50 miles per hour. How much time has passed when you've traveled 120 miles? Okay, so we have 50 miles per hour times some number of hours that we don't know gives us a total of 120 miles. That's one way to think of it. You may or may not have seen this before in your physics class, but if you take a rate times an amount of time, it gives you a distance. So another way to think about this is that we need to multiply 50 by something to get 120 miles. If you remember your equation solving, I'll do this in two ways. This is going to be 50 times some number of hours equals 120. And to solve that, we need to undo multiplication, so I'll divide by 50. And so h is equal to, just going to do a calculation here, 2.4. All right, so that's one way to do it. The other way you can think about this is if you take a distance, 120 miles, divided by a rate, like 50 miles per hour, the miles cancel out and you're left with the hours, and so that gives you 2.4 hours as well. Hours. Okay, order of operations stuff. So I'm going to write parentheses, exponents, multiplication and division happen at the same time, and then addition and subtraction. So I'm going to look for parentheses first, and so I see some. So I go in the parentheses, and then I think, what has to come first in the parentheses? Well, there's some exponents there, so I'm going to do that first. So I get 2 to the third is 8. So I'm going to rewrite everything else. Plus 10 minus 8 divided by 4 plus 3 times 6. Okay, we're still in the parentheses, so I'm going to do that. 10 minus 8 is 2, so that's 26 plus 2 divided by 4 plus 3 times 6. Alright, so I've taken care of the parentheses. Now I look for any exponents outside of parentheses, and there are none. So I'm done with that. Now we do multiplication and division left to right. So 2 divided by 4 is 0.5, or 1/2, you can write that too. And then I do 3 times 6, and that is 18, and the addition signs come along for the ride. So this is 26 plus 0.5 plus 18. We're done with multiplication and division. Now I do addition and subtraction left to right. And so 26 plus 0.5 is 26.5 plus 18. And then I do 26.5 plus 18. And I get 44.5. All right, that wraps up our homework. Thanks for watching.